Hello students, welcome. Today we want to do KCSE 2025 chemistry predictions. The code for chemistry is 233. We are going to do chemistry paper 3. Remember, chemistry paper 3 is a practical paper. Kindly stay with us until the end of the video. We are going to have 3 questions in chemistry paper 3 in this year KCSE 2025. The first question will be from the chemistry of the mole, that is titration, mainly back titration. It doesn't have energy change and it doesn't have rate of reaction, so graphs will not be there. So read on the back titration calculations. Question number 2 will be from inorganic qualitative analysis, that is the identification of cations and also anions. And question 3 will be from organic qualitative analysis or organic test. So as we have said, we are going to have 3 questions. Let's start with question 1. We are told you are provided with 0.5 gram of solid D. Roman 2, we are given sodium hydroxide labeled solution A. Then we are given 0.105 mole hydrochloric acid, which is labeled solution B. Then we are given 1.005 mole hydrochloric acid solution labeled C1. So we are told you are required to determine the formula mass of solid D. That is the aim of this titration experiment. So we are told procedure A. Roman 1, place solid B in a clean burette. So this is the B we are talking about with the molarity 0.105. So Roman 2, we are told using a bibate and a bibate filler, place 25 cm cube of solution A into a conical flask. So solution A is the sodium hydroxide, which is in our case the analyte. Then we are told add 2 drops of phenolphthalein indicator and titrate with solution B. Then Roman 3, we are told record your results in table 1, repeat the titration 2 more times and complete the table. So this is the table 1. So during the exam, this table is empty. So for us to fill it, first of all, it is good for a student to fill the initial burette reading to be 0, 0, 0.0, 0.0, 0.0. Then we do the first titration. We have gotten 27.2 as first titer. Then we subtract 27.2 minus 0.0. We are going to get 27.2. We do the second experiment again. So you can start with 27.3 where you have stopped. Then when you do the second iteration, you are going to have something to do with 54. Then the 54 cannot be shown on the burette. So you have to at least add some solution. Even you can put it 10.0, something like that, so that when you add 27.3, you are going to have your final burette reading to be at 7.3. So when you subtract the final burette reading minus initial burette reading, you are going to get again 27.3. So again, the third one, you can start 0, 0, 0.0. So do the third experiment, we are going to get 27.4. What we are going to have here will be 27.4. So fill in this table, we are going to have 3 marks. Sometimes it's carrying 4 marks. We are assuming it will have 3 marks there. So part A, we are going to have calculate the average volume of solution B used. So this part A is must to be asked and it's carrying 1 mark. So how are we going to calculate the average volume? First of all, we are going to check our 3 titrants, whether they are in the range of plus or minus 0.2. So when you check this one with this, it's having the range of plus or minus 0.1. This one with this, plus or minus 0.1. And this one with that one, plus or minus 0.2. So that means we are supposed to take the 3, we are going to add them, and we are going to divide by 3. So what we are going to get there will be 27.3 centimeter cube. This will be our average titer. It's carrying 1 mark. Don't forget to write the unit. It must be shown. After that, part B, we are told calculate the number of moles of Roman 1, solution B used. Moles or number of moles is given by molarity multiplied by volume used divided by 1000. So this will be equal to the molarity of solution B is given as 0.105 multiplied by the volume of solution B. Remember, that was the average titer. Even we are asked here, calculate the average volume of solution B. So it's 27.3 divided by 1000, which is in the formula. So when we put these values on the calculator, what we are going to get is 0.0029 moles. So Roman 2, solution A used. So this solution A has reacted with the solution B. And remember, solution B was the hydrochloric acid and solution A is sodium hydroxide. Let us write the equation for the reaction between sodium hydroxide, which is solution A, plus hydrochloric acid, which is solution B. What we are going to get is sodium chloride plus water. This reaction is self-balanced, so the mole ratio between sodium hydroxide and hydrochloric acid is 1:1. But we know the number of moles of hydrochloric acid that reacted with sodium hydroxide. It was 0.0029 moles. So we can cross multiply. What we are going to have will be 1 multiplied by 0.0029 divided by 1. We are going to get the same value. That is 0.0029 moles. Learners, remember, number of moles must be in 4 decimal points. You have to put it in 4 decimal points unless it is exact. Next, let's proceed to part C. We are told calculate the concentration of solution A in moles per liter. Concentration in moles per liter means molarity. So what's the formula for calculating molarity? It will be equal to moles multiplied by 1000 divided by volume used. So what is the moles of solution A? It is here 0.0029 moles. We have gotten right now. So multiply by 1000, which is in the formula, divided by volume used. What is the volume used of solution A? It was in the bibate and it was 25 centimeter cube. So when we put these values in the calculator, we are going to get 0.116 mole. So if you don't want to write M capital letter, you can write the unit as moles per liter, the way they have written there. Next, let's proceed to procedure B. We are told Roman 1, using a burette, place 30 centimeter cube of hydrochloric acid solution C1 in 100 ml beaker. We are told add all solid D to the acid, stir the mixture gently with glass rod. Then Roman 2, transfer all the contents of 100 ml beaker into 250 ml volumetric flask. Then after that, we are told add distilled water up to the mark. Label this solution as solution Q. Roman 3, we are told using a bibate and bibate filler, place 25 centimeter cube of solution Q into 250 ml volumetric flask. Then we add 2 to 3 drops of naphthalene indicator. Roman 4, then we are told rinse the burette thoroughly and fill it with sodium hydroxide, that's solution A, and titrate against solution Q. Then lastly, we are told record the results in the table 2, repeat the titration 2 more times and complete table 2. So let's proceed to table 2. So this is table 2. We have here the initial burette reading in centimeter cube. In the first titration, we have given the initial burette reading to be 0.0. Then after doing the first titration, we have gotten 18.9 as our first titrant. So 18.9 minus 0.0, we are going to get 18.9. So the second titration, we are going to start 0.0. We have gotten again 19.0. So 19.0 minus 0.0, we are going to get 19.0. Then the third one, 0.0, is our initial burette reading. Then we have gotten 19.1. When we subtract, we are going to get 19.1. So Roman A, we are told calculate the average volume of solution A used. Solution A is here. So let's check the 3 titrants, whether they are in the range of plus or minus 0.2. So this one with this, it's in a range of plus or minus 0.1. This one with this one, plus or minus 0.1. this one with this one is plus or minus 0.2. So that means the 3 should be added and divided by 3. That's how we are going to get our average volume. So 18.9 plus 19.0 plus 19.1 divided by 3. What we are going to get after putting these ones in the calculator will be 19.0 centimeter cube. Learners, when you are putting these values, first of all, when you say 18.9 plus 19.0 plus 19.1, say equal to, then divided by 3. Don't just put 18.9 plus 19.0 plus 19.1 divided by 3. It will give you wrong answer. But P, we are told calculate Roman 1. The number of moles of sodium hydroxide used. So what was the formula for calculating moles? It was molarity multiplied by volume used divided by 1000. So what is the molarity of sodium hydroxide? It is the one that we have gotten in procedure A. It was 0.116 multiplied by volume used, which is 19.0. We have gotten now divided by 1000. What we are going to get here will be 0.0022 moles. So remember, we said number of moles must be in 4 decimal points. Roman 2. The number of moles of hydrochloric acid in 25 centimeter cube of solution Q. Where is this solution Q coming from? This solution Q, remember, we have done it in procedure 2. That's procedure B. What we have done first of all was we have taken 30 centimeter cube of solution C1, that was hydrochloric acid. Then we have added all the solid D to the acid. Then when the reaction was over, then what we are told was transfer the solution into volumetric flask, and we have diluted, or we have topped up the solution up to the mark. So that solution was the one that was labeled as solution Q. Then after that, we have taken 25 centimeter cube of solution Q and we have reacted with the sodium hydroxide, which was from the burette, which its volume is 19.0. So that means the number of moles of this solution Q, we are going to get it using mole ratio. The mole ratio between sodium hydroxide ratio hydrochloric acid is 1:1. We know the number of moles of sodium hydroxide that reacted with this solution Q. It is 0.0022 moles. What about the one for hydrochloric acid? We cross multiply. We are going to get 0.0022 multiplied by 1 and divided by 1. It will be the same, 0.0022 moles of hydrochloric acid. That is solution Q. Next, let's proceed to Roman 3. We are told calculate the number of moles of hydrochloric acid into 250 centimeter cube of solution Q. Remember, previously Roman 2, we have done the number of moles of solution Q in 25 centimeter cube. So you say 25 centimeter cube will be equal to 0.0022 moles. What about 250? We are going to cross multiply. So we are going to have 250 multiplied by 0.0022 divided by 25. What we are going to get will be 0.022 moles. Roman 4. We are told calculate the number of moles of hydrochloric acid in 30 centimeter cube of solution C1. So this is how it is written today. But during the exam on Friday, you can be told to calculate the original moles of hydrochloric acid in solution C1. The original moles is what we are talking about. So moles is given by molarity multiplied by volume used divided by 1000. So we are going to get 1.05 multiplied by 3 divided by 1000. What we are going to get there will be 0.0315 moles. So next, Roman 5, we are told to calculate the number of moles of hydrochloric acid that reacted with solid D. So this solid D was the one that has reacted with the 30 centimeter cube of the hydrochloric acid, that is the C1. So first of all, we have gotten the original moles. It was 0.0315 minus the excess moles. That is the number of moles of the hydrochloric acid that has reacted with the sodium hydroxide. That is 0.022 moles. What we are going to get there will be 0.0095 moles. Roman 6. We are told calculate the number of moles of solid D that reacted with solution C1, given that mole ratio between D and hydrochloric acid is 1:2. So the mole ratio is 1:2. Then we know the number of moles of the hydrochloric acid that has reacted with D. We have gotten here 0.0095 moles. So we are going to say, what about the number of moles of D? So we are going to have 1 times 0.0095 divided by 2. What we are going to get there is 0.0048 moles. Then Roman 7, lastly we are told calculate the formula mass of D. So tomorrow we can be told calculate the RAM of element or metal D. So if we are told like that, first of all we have to get the formula mass. Then after that we can calculate the relative atomic mass of an element. So RFM or formula mass is given by the formula mass divided by number of moles or moles. So the mass given was 0.5 divided by the number of moles, which was 0.0048. When we put this one in the calculator, we are going to get 104 point something. So this is relative formula mass. We are going to put it in whole number, so it will be 104. Learners, that's the end of our class for today. Thank you for watching.